Hello, students. Welcome to Engineering Geology and Hydrology. Last lesson, we learned about landslide geological hazards. Understand the concept of landslides, field identification, and preventive measures. Today, we will learn another type of geological disaster often encountered in transportation construction: debris flow. In 1981, Chengdu Kunming Railway Train 442 fell to the bottom of the bridge, caused 275 deaths. In 2010, a special torrential flow in the northeast of Jiuzhou County, Gansu Province. All the areas in its path were leveled. 1,557 people were killed. Debris flows are responsible for all this misery. First, let's look at the definition of debris flow. A debris flow refers to an event in areas with poor geology, mountainous areas with steep terrain, due to heavy rain or sudden melting of snow, forming a type of sediment-laden flow. Intermittent special floods. Debris flow erupt relatively suddenly. Its harm is relatively great. For example, it took 50 years for the Chengdu Kunming Railway to be built. Debris flow have disrupted traffic on numerous occasions. The worst was on July 8, 1981. Chengdu Kunming Railway Lizhi-Yida Bridge was swept away by more than 800,000 square feet of mud. 442 train is moving. Some carriages fell to the bottom of the bridge. It left 275 people dead or missing. The Chengdu Kunming Railway was forced to suspend operations for 15 days. The mudslide also caused harm to the Baoqing Railway. Train services were discontinued in 1981 for up to 2 months. The cost of repairing the railway reached 400 million yuan. Landslides also caused serious damage to highway construction. Debris flow to people's lives and property, causing huge damage. Here is the damage caused by the mudslide in Gansu, Jiuzhou County. Debris flow damage to Beichuan County City. Debris flows are characterized by their fierceness and suddenness. Once a debris flow occurs, to our project construction and the safety of people's lives and property, it will cause great harm. Today we will start with the classification of debris flows, zoning and formation conditions, to learn about debris flows, and then learn how to prevent debris flows. Classification of debris flow. First of all, it is classified according to the composition of solid substances, and be divided into mud flows, water rock flows, and debris flows. A mud flow mainly refers to when the content of silt and clay between 80% and 90%. A water rock flow mainly consists of silt and clay, less than 10%. Powder clay content, between 10% and 30%. We call it a debris flow. The second major classification is based on fluid properties. It can be divided into dilute debris flow and viscous debris flow. Dilute debris flow is mainly composed of dilute slurry and sand gravel. Viscous debris flow is mainly composed of viscous slurry and composed of sand and gravel. It can also be classified according to the morphology of the watershed. Is divided into slope-type debris flow and gully-type debris flow. Slope-type debris flow mainly refers to watershed is less than 0.5 square kilometers. It mainly forms on hillsides. Basin is underdeveloped. We call it slope debris flow. Gully-type debris flow. The general drainage area is greater than 0.5 square kilometers. There are clear gullies, and the drainage system development is relatively complete. Zoning of debris flow. A typical mud flow involves an entire valley, can be divided into formation zones, flow area, and accumulation area. The formation area is located in the upper reaches of the valley. Most are surrounded by mountains on 3 sides. Surrounding mountains are high and steep. Malgrowth of vegetation, having a funnel-shaped or dendritic appearance with many branches, conducive to the collection of water and loose earth and rock. The flow area is mainly located in the middle reaches of gullies, mostly a steep canyon terrain. Debris flows can move quickly downstream. Accumulation area generally located at the foot of the gully slope. Open and flat terrain. The flow of earth and rock from the ravine is slowed by the terrain. Pile down. Formation conditions of debris flow. There are 3 conditions for the formation of debris flow: rich supply of solid matter, steep terrain, and plenty of water. First of all, abundant supply of solid matter has to be on a hillside or on the surface of a valley. There is a large accumulation of loose debris, easily washed by the current. Second, steep terrain conditions. The terrain is generally favorable for water pooling in mountainous areas. The velocity of water is large. The scouring force is relatively strong. Thirdly, abundant water-heavy or persistent rain. Form a lot of water. Mudslides are deadly. How can we prevent it? Mainly from the following 4 aspects of debris flow protection. It is mainly soil and water conservation, ballast drainage, and circumvention. Firstly, in terms of soil and water conservation, water and soil conservation mainly adopts flood drainage, slope protection, and vegetation protection. Make full use of retained precipitation to conserve soil and water, regulating runoff and other functions, to prevent and stop the occurrence of debris flow, or to reduce the size of the debris flow. The purpose of reducing the damage degree of debris flow. Main focus is carrying out protection measures in the area where the debris flow forms. Soil and water conservation is mainly used in the formation area of debris flow. These 2 pictures show examples of flood drainage systems. It can also protect the loose soil on the slope. At the same time, it can be protected by vegetation. By planting grass, spraying grass, planting grass, and planting trees. It acts as a flood detention and soil consolidation on the slope, intercepting stormwater. To slow down surface runoff. It can effectively prevent water and soil loss on the slope. The second measure involves the use of check dams or debris flow barriers. Ballast engineering is the main engineering measure to prevent the damage of debris flow. They are constructed in areas prone to debris flows. A lateral blocking structure. The main function is to filter soil and drain water. Then we often use ballast blocking measures in engineering. It mainly includes gravity dam and grid dam. This is the grid dam. Compared to a gravity dam, the main advantages of the grid dam are good stone drainage effect, and its structure is relatively simple. The construction period is relatively short. The project cost is relatively low. Now it has been widely used and developed at home and abroad, when our roads and railways were laid out. Generally, relatively flat sedimentary areas are selected to pass through, like a tree root. Disjointed sedimentary area. How to ensure the safety during the construction of roads and railways, as well as in operation, mainly in the debris flow accumulation area. Building drainage channel, diversion dike, open tunnel aqueduct, and other measures. These are the drain channels and a diversion embankment. The drainage channels are primarily constructed by hand or by retrofitting trough-shaped structures. Divert debris flow to designated area. The main function of the diversion dike is improve the flow of debris flow. It can also regulate the flow rate. Open tunnel aqueducts is mainly built in the area where debris flow flows. Open tunnel aqueducts are often set up in areas intersecting with railways and highways, allowing debris flow through the upper aqueduct to protect the safety of road and railway facilities. Passing round. Under what circumstances should devious measures be adopted for debris flow? For debris flow damage is relatively large sections, we can take evasive measures. The threat of mudslides can be avoided by building tunnels or building bridges across rivers. Set up on the opposite shore. Man lives in nature. Massive transportation construction. To balance of nature. Cause great damage. Prevention and control of debris flow disaster. We should be in awe too. Take the initiative to coordinate it from a human perspective. Adapt to it. Protect it. Believe through the above introduction. The students have a deep understanding of the debris flow. Let's summarize this briefly. Firstly, definition of debris flow. Mudslides refer to mountainous areas with steep terrain and poor geology. Due to heavy rain or sudden melting of snow, formed a special intermittent torrent carrying large amounts of silt and rock. The classification of debris flow can be classified according to solid material. It can be classified according to fluid properties. It can also be classified according to the morphology of the watershed. The zoning of debris flow can be divided into formation area, flow area, and accumulation area. The formation conditions of debris flow mainly include 3. 1. An abundance of loose solid matter. 2. An abundant source of water with hydrodynamic force. 3. Steep terrain. All 3 elements are indispensable. The prevention and control measures of debris flow mainly include soil and water conservation, ballast blocking, drainage, and avoidance. In addition to debris flow, earthquakes can cause significant damage to our transportation infrastructure. In traffic construction, how to implement earthquake proofing, vibration isolation, and shock absorption measures. Let's study together next time.